So I'm Russ White, and I am here to talk about a little bit about Bgp Security Overview. I've been working in this space for, 15, 20 years. I'm getting too old to remember how long I've been working in spaces, so that's okay. So this is about BGP validation, and I'm really not trying to give you a lot about the technology. I'm really just going to give you a little bit of an overview of where we are. When I first started at LinkedIn, I walked into the office my first day and was told that BGP security was very important to me. So I said, yes, BGP security is very important to me. That's what working for a social media company does for you. You become a drone. So anyway, so we're going to talk a little bit about what the problem space is very quickly. I'm going to talk a little bit about what is going on in the space right now, what some of the solutions are. So origin and path validation are the two things that I'm concerned about in BGP security. And for me as an eyeball company, this is what I care about. I care about that when you hit the LinkedIn web page, your route, the route back to you is not hijacked, and or the route to my Anycast address is not hijacked, depending on where you are. So we use all Anycast at all the edge, so we really care about this stuff being right. So in this particular case, I'm going to talk about who really owns 2001 DB801/64. So let's say I have two ASs down here that are both advertising this route. How can AS 65000 actually know who originated that route? So one thing important to note here is that origination is generally implying reachability, right? So I have to be concerned about whether or not it's reachable. I assume that if you own the route, you actually have the subnet in your AS. That may not be a valid assumption, okay? But that's what we're assuming. This is one of those tricky things about BGP security is IP is packet switched, so therefore the AS path doesn't necessarily have anything to do with the actual path of the packet or anything like that. So I actually wrote an RFC on this. It's an individual contribution if you want to look it up. So one thing we're concerned about is valley-free routing. We want to make sure that beyond just the origin of things, we want to make sure that AS 65000 is advertising to 65002 some route because AS 65002 is taking in partials or fulls. I want to make sure that 65002 doesn't resend that route up to 65003 and actually become a transit when he shouldn't be, right? This is a huge concern for most edge providers, that they are very concerned about this valley-free routing thing. A third thing that I keep running into is there are an awful lot of transit providers in particular that don't want information about their connectivity to be leaked from outside of a particular range in a legally defensible way or a legally binding way. They want to be able to, they're very concerned about, particularly for instance, I am a large transit provider and I have subsidiaries in Japan and I don't want anybody to know that they're my subsidiaries. So I want to be able to say that I'm connected to them without saying I have a legal relationship with them. So there's types of things that run into here. So I want to be able to control things. And I want to be able to do regional routing. A lot of IXPs are very concerned about being able to do regional routing and not having things leak out of a region. Do you like this picture? This is really good, right? They lock the gate open. This is security in the modern network, right? They lock the gate open. Anyway, so there's operational requirements. Don't replace the edge. I peer with, I don't know how many people, 200, 300, 1,000, because I don't do the peering part of the LinkedIn network, but I know it's a lot. I can't afford to replace all my eBGP speakers with a brand new router that can do some sort of fancy new stuff. And I know Level 3 can't, and I know that many other companies can't. Don't tell operators how to run their networks. This I hear from NTT Level 3, Work Online, Deutsche Telekom, BT, all of them tell me the same thing. Don't tell me how to run my network. Don't slow down convergence and be very, very quiet. Okay, don't slow down convergence is very simple. Consider for a moment that you're a small municipality and you are under DDoS attack. So you pick up the phone and you call some friendly DDoS attack company that will actually scrub the traffic for you. And you say, I need you to pull my traffic out of the BGP table and I need you to be able to scrub my traffic and tunnel it back to me right now. And the DDoS protection company says, we'll do that for you in 24 hours when BGP converges. You're not going to be a happy camper. So we can't do that kind of thing. The other thing is be very, very quiet. I don't want to push out any more information than I'm already giving out by just advertising routes. Okay, there's information here that's important to me that I don't want to do anything with, and I don't want a single point of failure. Okay, so here's the Rpki. This is probably what you've heard of before. This is an IETF standards track document. So here what happens is the originator who owns the route goes to their RIR and gets a route origination certificate, or an ROA, a ROA, and that is signed with the RIR or the NIC's private key. So then they advertise this is pushed into an rsync database. Today it's rsync. It's synchronized to everybody. You can synchronize to this database, which is essentially an IRR mirror, but it's much slower. It takes about 24 hours for this to update today, from what I've heard. 6 to 24 hours, depending on how close you are to the rsync master and things like that. So you essentially pull this, and you can use this to just check the origin. You can't check, it's just the first hop AS. This is all you can check with Rpki. So again, AS65000 can use a local database, check the resource certificate, which is based off the ROA, and it can actually determine which of these two ASs down here at the bottom actually owns 2001 DB801/64. So how are these carried? I just told you they are carried through an rsync process. It's very slow today. People are working in this area trying to make this better. So how does the actual router check the edge connection? Well, there's a lot of different ways. Again, I don't want to tell a provider, particularly a transit provider, how to do their business. So there is an Rpki router, Rpki2 router protocol that has been standardized in RFC 6810. Juniper has actually implemented this. I'm pretty sure Cisco has implemented this. A lot of vendors have implemented this, but you don't have to use this if you happen to be a transit provider or an edge provider or even a content provider that has your own policy mechanism. You can feed this stuff, this Rpki database, into your existing policy mechanism and use that instead. Let's talk about Bgp Sec. This is actually what's under consideration right now. It's going through the standards process. The argument, I think it's going to become a PS, a proposed standard in the IETF. So what this does is slightly different. What I'm going to do is I'm actually going to, at my eBGP speaker, take that ROA, I'm going to sign the AS path, and I'm going to forward sign the AS path. I'm going to put in the AS path, my AS plus the AS I'm sending it to. I sign that using my private key. I stick my public key in the ROA. It's synchronized via rsync. And I put all of this other information in there. There's a new attribute. It has the signature, which is basically just a hash over an X509 type thing. It has the private key retrieval information. It has a URI in there that allows you to retrieve it. Has a valid lifetime, other information, things like that. Certificate is around 256 octets in total. Now what happens is this is actually signed on a per hop basis. So you sign the outer one, or the first AS65000 adds this attribute, signing over 65000, 65001. AS65001 adds another copy of this attribute onto the route, signing across AS65000, 65001, and 65002. So it's like an onion peel. So when somebody beyond 65002 gets it, they unpeel the onion by looking at everyone's private certificate, running all the certificates. We're using the public key to validate the hash on each one of those signatures and make sure that the AS path is correct. Analysis. So this is my analysis of Bgp Sec. 100% positive attribution of AS path. Is this useful? Yes and no, right? Because what did I say in the first? The path of the packet doesn't necessarily follow the AS path. So this is a difficult thing to do. Validation is advertised inbound, which means it follows routing information, which means it converges at the same speed as routing. However, it defeats specific classes of man-in-the-middle attacks and protects against one-off attacks. In other words, I can't say I'm attached to 65002 and 65002 is the correct originator for a particular destination. However, negatives, 15 times the table size on average. So whatever you are advertising through BGP today increases by 15 times. This is not a good thing. Precludes packing and other optimizations. I said they are attributes. So you do packing based on attributes. So therefore, every route has to be advertised in its own TCP segment or in its own BGP advertisement. Signature is processed per AS hop. You can imagine this is an X509 certificate that is using triple DES, or I don't know exactly what there's key agility. So there's different algorithms you can use. This is a huge problem from a performance perspective. I had to replace all my edge routers to do this. Replay attacks are possible. You might remember I said that there's a timer in there, because once I've advertised something that's signed and validly signed, what's going to happen if somebody holds onto that advertisement and then they continue advertising it even after I've broken my peering relationship with them? See, they can still consume my traffic and it still looks valid cryptographically. So you can replay attacks so long as the timer doesn't invalidate, or as long as you don't send out a key revocation. And attacks against the time system can impact the entire routing system. There was actually a research paper done on this really recently, talking about they actually set up this BGP second thing in their lab, ran attacks against NTP, and blew the entire routing system up. Another thing is that you have to figure out how to handle your private key. You need to stick your private key on every edge router, every eBGP speaker, which then makes the private key vulnerable, because anybody just has to break into one of your eBGP speaker among thousands, and it destroys your entire private key. You have to roll your private key, which is a real pain. Or you have to give every eBGP speaker its own private key, which is typically how this is deployed in the real world. But that happens to mean that if I give every speaker its own key, I now can look at pairs of speakers in the internet topology and not just pairs of ASs by looking at the BGP table. It's really bad to me. This is a huge information leakage. So let's talk about a DAG, or directed acyclic graph. This is actually based on AS level semantics. Only AS level changes are reflected in the base advertisement. So what happens here is 65,000, 65,002 advertise they're connected to each other. They do it through a certificate that's signed with their private key. And again, you use your public key from either Rpki or from some other system to do this. So you can actually include more detail in such a graph. There are kind of quasi-experimental implementations of this that include other information, which neighboring AS is a transit, which is not, etc. So you can just say, when you receive a route that says AS 65,004, 65,003, you look at your graph and you say, is AS 65,004 connected to 3? Is there any policy? Am I connected to 65,000? So I'm 80% certain the route is valid. It doesn't prevent some types of attacks, but it doesn't have replay attacks. The idea being to leave it to future reactive systems to resolve the rest, do some research. So in operation, you would have an overlay carrying new information. You could carry it in BGP. By the way, a lot of providers object to this, and I'll talk about this in the analysis. Can be carried as multi-hop, can be carried edge to edge, and each AS can make a different decision, allows for incremental deployment. So there's a potential address family format. You will be tested on this at the end. Denise has the test in the back. She's going to hand it out in just a minute. Did I leave it up long enough for you to memorize the AF format path? No, okay. All right. So, analysis. Validates the AS path. Validation advertised in an overlay. Does prevent certain classes of man-in-the-middle attacks. Protects against one-off attacks. Can use BGP. I have uses BGP up here. But again, some people object to this. So some negatives, some specific providers have told me they do not want to overload BGP with this information. Doesn't provide the strongest level of path protection. And again, remember what I said at the beginning. Some providers are very, very nervous about advertising their connectivity in a way that is legally provable. So they're very concerned about saying, I'm connected to AS 65,004, and I'm going to sign that I'm connected to AS 65,004. Okay, so in short, this is probably not going to deploy either. So what I'm working on right now is, what I'm trying to get done right now, we'll see how far I get with this. How's that for an answer? It's not just me. There's a small group of people. I have NTT, Level 3, and a group of people actually working on this with me, Work Online, etc. CHI-NOG, LACNIC actually, and some of those guys are working on this with me, is to allow people to use Rpki. There's actually a draft out that will allow you to add connectivity information into the Rpki. So you can actually take the Rpki information, you can add your list of neighbors to that Rpki information. So for me, as an eyeball provider or as a content provider, I'm perfectly happy with Rpki as a solution. It's fine with me. I'm not transit. I'm not worried too much about the heavy overhead and everything. So then I can use an RPSL or a public RIR using public RIRs. Now, the public RIRs are notoriously horrible in the types of information they have. It's actually not as bad as it seems. There have been some studies on it using CADA's internet graphs against the public RIR information. It's not that bad, but nonetheless, there it is. We need a signature on top of RPSL. There are proposals out for this. We're working on others. And everything could be pushed into the RPSL language that the RIR does. Then we also have private RIRs. For instance, Level 3 and NTT run their own private RIRs. And those RIRs are just their customers. So if I can mirror their Level 3 and NTT's IRRs and work online and whoever else happens to have one, I have yet another information source that I can use, because I'm pretty certain that Level 3 keeps their IRR updated with their customer list, and NTT I know does. So, I can start using that information. Then I can do table analysis. I can use CADA, and I'm actually talking to CADA a little bit about trying to give me some table analysis tools that are open source that people can use. So I can take all of these and I can actually feed them into a local IRR mirror. And one of the things I'm working on with LACNIC right now is an API that will run between the Rpki ROAs and an IRR mirror. So I can do an IRR query and it actually hands me back the Rpki information in RPSL format. I can take all of this, I can shove it into through a local policy layer. So I can say, I really want to believe private IRRs over public IRRs, and I want to believe Rpki over both of these, and then I want to back into route views analysis to condition this data in some way. I could actually have a local policy layer, which I would like to see someone build in an open source format. This doesn't exist today. And then I can actually have my local valid route information that then when I receive a route, I can actually use routed Rpki or local policy type stuff to get that information into my acceptance or rejectance of the route, or setting local preference, or using cost community. I would probably use cost community to back up against local pref or that type of thing. So this is kind of what we're working on right now, as I'm trying just to work with a small group of people to actually start deploying this. We're not approaching the IETF with this. We're not taking this into any forums like that. We're just working individually to try to get our companies to work together on this and get this running. And I figure if I can get 2 or 3 big transits and LinkedIn and a couple of other content providers to buy this and deploy it, then we can actually start a nub of a program that allows us to start rolling this out to other people. And a lot of it's going to be trying to build all of these tools and get all of this tooling in place in a publicly available open source way so that people can use them without paying a lot of money for them. So analysis, validation of origin through Rpki and IRR, to some depending on what people have done for signing. Validation information carried outside the routing outside the routing system, which makes some people happy. I frankly don't care. I think BGP is a well-used tool. Should I say overused tool? We use it far too much for too much stuff. But no single point of failure or control. One of the objections that I hear from transit providers is this. If I actually go to a transit provider and I say, I own this address space, and I ask them to sign it for me. Now let's say that I'm working with JPNIC, and I'm actually a US headquartered company. And let's say some clerk or some admin person forgets to write a check to JPNIC this month. And now my Japan originated traffic goes away because I lose my Rpki validation certificate because someone forgot to write a check. The business impact is absolutely huge to a transit provider, even to a content provider. The business impact is huge. So a lot of the transit and content providers are saying, we don't want a NIC to be able to control our business. So therefore, this is a huge issue. This whole trust, no single point of control or failure is a huge issue, okay? Or you can imagine other instances where some government decides to shut down a website by pulling the Rpki certificate for that particular address space, and it becomes a free speech issue, right? So there are all sorts of issues around this that need to be dealt with. Local policy shaped from multiple sources. Negative, lots and lots of moving parts. I don't like lots of moving parts. I'm a simplicity guy. I don't like all this complexity to solve what I think is not a simple problem, but we're certainly building a Ruby Go-board contraption here, right? We're putting a lot of pieces in place to make something that shouldn't be too difficult to do. No single point of control is also a negative from some perspectives. DoD and Department of Homeland Security would certainly like to see a single point of control to be able to take down sites that are pornographic or whatever the case might be that they want to get rid of. Receiver-focused trust model, which means I have to be intelligent enough to know that IRR information received from NTT is probably more reliable than IRR information received from a public IRR. But it comes down to me running my network correctly, and not everyone runs their network correctly, right? We know that. And the current IRR model is broken. The public IRRs still need to be cleaned up and fixed. So there's a lot of problems to resolve here that need to be dealt with. RPSL needs a way to restrict propagation, signing semantic key resources for RPSL objects. Need to be able to access all sorts of information from a single API, so I need to get this whole thing with LACNIC going. Route views information, all this other stuff, local policy store. We need some open source commercial tools in this area. So questions or comments? And if you would like to play in this space, you can email me. I don't know how much you could do right now, but if you own a transit or an edge provider, I'm interested in talking to you about doing this. Oh, Avi's up at the mic. He's going to present me with the problem of evil. Go ahead, Avi.
Not a problem of evil. Two questions. One, are you hoping to do this inline? So you're in band, on routers, live with updates?
No.
At some point? Okay. So just detection to start, see how it goes, and then
right,
decide what to do.
Right. So an overlay,
right.
A virtual overlay using rsync and IRR synchronization, stuff like that to do this.
Cool. I still think if you're going to do that, it could be done in adder, delegated, but whatever. So second question. So I can still forge your origin, right?
What's that?
I can still create a, whatever. I can still create a route.
Yes.
That takes you for granted. Right?
Exactly.
On the back
so
end.
that's on me.
Because I can grab the actual route and then
right.
I can grab the actual object and then create an AS path in the middle and then redistribute it, so I can hijack you with this.
Exactly. So that's up to everybody actually telling me what their connectivity is, which they may not be willing to do.
Okay.
Right? So I'm hoping that the average AS path is 4 hops. I'm hoping if I tell people who I'm connected to, and Time Warner tells people who they're connected to, that level 3 telling me who they're connected to won't make any difference.
Got it.
Right? That's what I'm hoping.
Right. To the extent they're willing to expose their connectivity.
Exactly. I'm hoping enough people are willing to expose their connectivity to make the two-way or the checks actually worthwhile. And Avi was talking about, we had discussed in the past, actually creating a new in-edge ARPA space and just putting this in DNSSEC, which is a really cool idea because DNSSEC's already signed, it's already root zoned, all this stuff is already done. However, there seem to be major objections to this in the provider community that I don't understand. So, yeah, I don't understand them, so I'm tired. We argued this when I was at VeriSign Labs, and I couldn't make any headway then, and I'm not making any headway right now, so I don't know. Any other questions?